In this series of videos I'm attempting to repair and restore a pair of HP9120A printers. So far, as you can see, I completely dismantled one of the printers. This is the print mechanism. Excuse the gloves, I've replaced the roller on this. I'm trying to avoid getting too much grease and dirt onto it. So I'm at the point now where I can start reassembling this print head. Now before I can do that, there's just a couple of issues I need to deal with. Now the observant of you, the eagle-eyed, will have noticed when I dismantled this there was a part missing. I didn't mention it at the time. In fact, I did mention it at the time, but I edited the comment out of the video because it was proving too difficult to explain what the part did without it there. So I decided to post this completely separate video on the subject. Also, it's a fairly interesting subject in its own right, so I thought it warranted a separate video. So in the previous video I made this replacement roller and replaced the rubber on it. And when I took this apart, if you go back and look at the videos, you'll notice that there was a one-way drive Sprag clutch on one end. So that's this. So if I refit this, it was fitted like this. Now what it's for, it's a one-way drive. Another, you won't be able to see the roller turning very well. What it does is, if I turn it one way, if I hold the roller, I can turn this quite easily in one direction, so it turns quite easily in this direction, but when I come to turn it the other way, it grips very tightly on the roller shaft. In fact, the more I resist the turning, the more tightly it grips. It's a bit like a Chinese finger puzzle, and but it will still turn back the other way. So the idea of this is a one-way drive, and this works in conjunction with this part of the print head, and this just rocks back and forth using this spiral. So each time the head moves across, it causes this to rock once, and that in turn causes the roller to advance the paper by one character height plus a little bit, depending on how far this turns. But of course the problem with this is, once it's turned, the roller, which is this direction, when it tries to turn back, there is still some drag on the roller. So without there being kind of some resistive force the other way, what will happen is it'll just keep rocking back and forth. Now there is of course some drag if the paper's fitted, and there are some fingers that also run along the roller, so it's kind of may work without the second of these Sprag clutches fitted, but it's very unlikely. You get very uneven spacing of the characters if it would work at all. Now if you look at the videos I took this apart, you notice that the second of the Sprag clutches, which is this spring here, should sit at this end. But there was nothing there, it's not fitted at all. Now at first I thought maybe it was a factory manufacturing omission, but looking very carefully I could see that there were marks at this end, so it had originally been fitted. So it looks like somebody's had this apart and maybe not really understood the importance of the Sprag clutch, and there needs to be one at both ends. The idea of this is the one at this end drives the roller, and then when this is rotating back the other way, the other one grips and it prevents the roller from turning backwards. So it acts like a very fine resolution ratchet system. But as I say, the one at this end was missing. Now the difference, this one is wound clockwise and this one is wound anti-clockwise, so that they're not the same. Also, they're not really standard springs. They're made of square cross-section spring wire. So they are a bit of a pain to replace, and of course you can't get originals, so I was going to have to make one. And normally it's not the sort of thing I'd show in a video, but it's quite an interesting subject, so I thought it warranted a video in its own right, so that's what this video is about. If you're not interested in springs, then please skip the rest of this video. Now the first thing with springs, especially if you have wound any of your own, is they quite often are misunderstood. And if you take a standard spring, a tension spring or a compression spring, they're normally made of round section wire, and it's just coiled around, and depending on whether you pull or push it, it will act as a spring. But quite often what's not understood is that springs don't, get an example of a spring here, it's quite easy to think that they work in a kind of bending motion, but the wire doesn't actually bend. The spring works by putting the wire in torsion, so in a coil spring that's round. Each section of the spring wire, as you compress or stretch the spring, you're actually twisting the wire, you're not bending it. And that's important to understand if you need to coil or make a precision spring. And most springs, it doesn't matter, you can just wind the spring to something close and it will work. But this spring needs to be a very specific diameter within about 0.1 millimeters, and it also needs to be a very specific force and coil spacing for it to work correctly. It also needs to be square section wire, which is a pain to coil for obvious reasons. So all those things combined mean that this is quite a challenging spring to manufacture. But because it's missing and there's no way I can buy one, I was going to have to make one. So how do you go about doing something like this? If you're not familiar with winding springs, there are some fascinating elements to it that I thought I would briefly cover in this video. As with many things in engineering, the more you look into a subject, the more there is to learn, and I learn many new things every day, which is one of the reasons I do this. So the first thing to bear in mind, if we look at this spring, there's obviously quite a lot of spacing between the wires. So before we consider a square section wire, we'll consider a round section wire. Now if you just take a piece of wire and coil it around a former, so if you just, for example, put a piece of rod in a lathe and let a piece of wire wrap around it, or if you manually wrap the wire around, you'll end up with something that's fairly loose. So like this, probably hard to see. I can't zoom in, I don't have a macro lens before anyone complains, but notice this is kind of quite loose. But if you want to have the wire spring so it's kind of pulling itself together, what you do is once you've got the start of the spring attached to your former, you pre-twist the wire, and depending on which direction you twist the wire before you wind the coil, you'll either cause the coils to open out like this. This is assuming you're close winding them, or they'll do the opposite, and you end up with a spring that's a bit like this, which is pulling itself together. So the coils are trying to get closer together, and they're actively pulling themselves into a tight spacing, and that was by virtue of putting a twist in the wire before winding the coil. Now the difficulty with this, of course, is if it's a round wire, it's fine, you end up with still a round wire, but you can't do it like that for a square cross-section wire. So if we look at the wire, so this is a section or piece of the wire that I used to make the Sprag clutch, you'll notice that it's square in section, and so you can't just arbitrarily twist it, because otherwise you end up with a very weird looking spring and it definitely wouldn't work properly. So the way you have to go about doing this, or at least the way I do this, is I start off by making a guide. And this is all arranged in a lathe, so I start off with a guide and a former. The former has a hole, and depending on which direction you need to turn the spring, you can either rotate the lathe backwards, or you can put the hole at the other end and wind the spring the other way. What happens then is the tool that I've made, and this is just a piece of brass with a slot cut in it that is 0.1 millimeters wider and 0.1 millimeters deeper than the wire, so it's got a square slot cut down its length, and that means that once the wires fit into it, it's controlled, it can't twist as it goes out onto the former. This is then put into the tool holder on the lathe with a steel block on top of it. The former goes into the chuck, the end of the wire is fed into the hole, the ends bent over, a couple of turns put on to take out the loose part of the wire. This is of course being fed from the tool holder. So what you then have to do is set up the lathe to wind the spring. So this is obviously in the chuck of the lathe, this is in the tool holder, and what I then do is set the lathe up as if though I was cutting a thread. The cross section of this piece of wire is 0.7 millimeters, so I set the lathe up as if though I was cutting a thread with a pitch of 0.7 millimeters. Then for each revolution of the coil, the tool will move along by 0.7 millimeters and keeps the spacing correct. I've got a photo of the setup here. I didn't video it. It's not really very easy to video in the workshop. It's too dark in there. But there's hopefully this will be fairly clear as to how the lathe was set up. We've got the tool in the tool holder. The wires pass through it, through the hole in the former, and then the lathe is set up to run very slowly. It's set up at 65 RPM, and you just make sure you turn it in the correct direction to give you the spring that you want. What you then have to do, of course, if you've ever tried winding a spring, you'll know that this spring was wound on here, and you can see that as soon as you release the tension it pops open. So you need to make sure that the diameter of the former is correct, and the smaller this gets, the more impact its diameter has. So for a 10 millimeter former with the tension I was using, I was getting something like a 16 millimeter final inside diameter, and if I took 0.2 millimeters off this, then it would change the final inside diameter by 1 millimeter. So it has to be fairly accurate, or at least it does for this application, because we need to get within about 0.1 millimeters of the correct final inside diameter. This was an example I wound just to show how you then control the spacing of the coil. What we want, of course, is one that matches the original, which is very close spacing. So this is where it gets a bit more complicated in how you go about controlling this for a square section wire. And what we want to end up with, of course, is something that looks like this. So this is our final spring. The inside diameter is 14.05 millimeters. I was aiming for 14, so it's very close to exactly the right diameter. It's got the right number of turns, and it's wound in the right direction. So but as you can see, all the windings are side by side, but also it's pulling itself together, which is one of the things that we wanted. So to get control of how tightly the windings are spaced and how much they pull themselves together, you have to pre-form the wire. And it's not quite as obvious as it might seem as to which direction you do that. So if you imagine you're winding the wire like this, then if you pre-form the wire, and this is the amount of pre-forming I put into it, you can see it's about a 300 millimeter radius bend that I ended up using. But if you put this in with the curve facing kind of upwards, so in this direction, then you'll end up with an artificially spaced winding. So these are all wound the same. So before it was taken off the former, it looked like that, and as soon as tension was released, it sprung out like this, and that's with the curve, the end of it kind of going upwards. If you turn it the other way up, then it will do the opposite, and it will cause the set in the spring to try and pull itself together rather than push itself apart, and that's what we were aiming for. If you put them in sideways, you just get ambiguous results. So preset or preform the wire, put it in so that the curve faces down, so it's kind of like this. And what happens then, and this is assuming that you're going to wind it this way. If you're winding the other way, then you do the reverse, of course. So if you preform the wire in the opposite direction to the direction you intend to wind it, you will get a very tightly spaced coil. If you do the opposite and you preform it in the direction that you intend to wind it, you'll get the opposite. You will get a very loosely spaced spring, and the spacing will depend on, to a large degree, how much of a preform you put into the wire. So I hope all that made sense. And what you can do is make very nice, tightly controlled springs. I made several of these just as experiments. But I have ended up with one that's exactly the right size for this application, and it works. So if I assemble all this, then it will allow me to use this as a ratchet. Again, you probably can't see, but if I try and turn it this way, it turns very easily. If I try and turn it the other way, then it grabs and grips onto the shaft and it's turning the roller. Whereas if I turn it backwards, it doesn't. So this now works as a pair. So if I hold on to this one, if I turn it this way, it turns the roller. But if I try and turn it back, then it won't allow the roller to turn, but it will allow this to rotate back to its start position. So it acts like a nice double acting clutch, which is exactly the way it's supposed to work. Okay, well, I hope some of that made some sense. This is one of the things sometimes you have to do with old equipment like this, and you have to be fairly inventive in some of the tooling that you make. If you're interested, the wire I used to make this spring is this. It's actually meant for cutting out car windscreens, but it's stainless steel and it has ideal tempering for making springs. And as with any spring wire, it means it's quite difficult to get the final diameter, but that's what you need in a spring. It's fairly cheap. If you try and buy square section actual spring wire, it's horrendously expensive. I think I paid something like £10 for this. And there's 22 meters on here. You only need probably 1.5 meters for each of the springs. So it's quite a cheap way of doing this, and I think the cheapest quote I could find for square spring wire, I had to buy 1,000 meters of it, of this size that is. I had to buy 1,000 meters and it was going to cost me something like £600, so that was not really an option for me. But this is a very good solution, and as you can see, it gives what is quite a nice result, and it looks identical to the original. If we look at that close up, you'll see that it looks very like the original, just not quite as rusty. Okay, if you have any questions on that, then please leave a comment.